All right, so in exercise 1 here, we're going to continue our look at exponential growth, and we're looking at the thickness of toilet paper, something that, maybe you never pondered before, but maybe you have. It says it is 0.001 inches. Now, I'm not sure if that's 1 ply, 2 ply, or, whatever kind of ply, but anyway, we'll just go with it here because that's what the problem says, right? So it seems pretty thin. Let's see what happens when we start folding toilet paper, though. Okay, so in letter A, it says, how thick is the stack of toilet paper after 1 fold, after 2 folds, and then after 5 folds? So let's take a look at that, right? So there's our, no fold. So then for 1 fold, and maybe I could do it this way. Let's do it this way. Thickness, we'll say there. Okay, so 1 fold. Well, what would happen? What happens to the thickness when you fold it? If you fold it in half, right, it doubles the thickness, so it'll be 0.002. Then with 2 folds, we'll double it one more time, so it'll be 0.004. And then with 3, and then 4, and then 5 folds, 0.008, 0.016, and then 0.032. So there's our answer for 5. These are all, of course, in inches. Write an explicit formula for the sequence that models the thickness of the folded toilet paper after n folds. So, we're going like dot, 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 dot. What if we have n folds then? Okay, well, so again, let's think about what happens, right? We started with this 0.001, right, and we're doubling it every time, okay? But for no folds, right, it stays at that 0.001. So I think here, right, we can just say n, right? If we put 0 folds in, if you put 0 in for n, 0 folds, then the 2 to the 0 will just be a 1, and this will just be 0.001 then, right? Then when you have 1 fold, it'll double, so it'll be times 2, which gives you the 0.002, and so this is going to be our, we can put it like f of n equals like that. After how many folds will the stack of folded toilet paper pass the 1 foot mark? Okay, so we want to know when is the thickness, which is, our y value here, when will that be 1 foot? So be careful here, right? We're talking about 1 foot, but what are the units for our thickness here? The units are in inches. So we need to change this 1 foot to inches. And then we'll set that equal here to find the number of folds, right? If we're trying to find how many folds, that means we're solving for n. So we're going to figure out this n here. So you can do that by, well, let's isolate the exponential term here. So we'll divide both sides by 0.001. Okay, and so 12 divided by 0.001 is actually not as hard as you might think. It's just 12,000. And we have 2 to the n. Okay, now remember we got to get this exponent, this variable out of the exponent here, so we'll use a logarithm. And let's use log 10, just like the log, right? So we'll do log of 12,000 equals log of 2 to the n. That allows us to bring that n down out front there. So we'll have log of 12,000 is equal to n times log of 2. Divide both sides by log of 2. And we'll have, and is exactly log of 1,200 divided by log of 2. Or, which we really want an approximation here. Okay, so approximately 13.55. Or in other words, we'll need how many folds? 14 folds. Okay, to pass that 1 foot mark. 13 folds will be too short, right? We need to go over 13, so that means 14 folds. Now, the other thing you have to concern yourself with here is that you can't fold paper infinitely, right? At some point, it won't stay folded, and so that's something you also have to think about too. So you might not be able to fold the toilet paper 14 times. All right. The moon is about 240,000 miles from Earth. Compare the thickness of the toilet paper folded 50 times to the distance from Earth. Okay, so let's go ahead and see 50 times what that would be. So we'll put it into our function there. So f of 50 equals 0.001 times 2 to the 50th. Okay, and that's going to give us a number of inches. Now, if we type that into our calculators, I have a feeling this is going to overflow the... Oh, no, it did give me an answer. Okay, but it gave me a really big decimal. In fact, I'll go ahead and show it to you here. 0.001 times 2 to the 50th. Okay, get a big number. But let's go ahead and convert that. Remember, that's the number of inches. So if we want the number of feet, we'll divide by 12. There's the number of feet. Okay, 9.38 times, and that E there means 10 to the 10th. Okay, but we want to get miles, and there's 5,280 feet in a mile. So if we divide this answer by 5,280, you'll get the number of miles. And there's the number of miles. So it is 17,769,884.89. Okay. All right, so that is equal to 177,69884.89. Okay, just like that. And again, we'll put our commas in there. And that's supposed to be a 7. Looks like a 2. There we go. And that's in miles. Okay, whereas the moon is 240,000 miles from Earth. Okay, so you can see here that folding that toilet paper 50 times, okay, is going to get you something that's much farther in length than the moon, right? Which again, this kind of like blows our minds a little bit, because like, how can you fold a piece of toilet paper so much that it would be this, length, as opposed to the moon, which is only 240,000 miles away, right? So that seems like a kind of a silly thought, because again, we can't fold paper that many times. It's just not going to happen. All right, in exercise 2, we'll take a look at that rare coin.